That's chapter 1. All right, so chapter 2.1. We're going to try and cover these topics. All right, chapter 2. 2.1. All right, so we've dealt with the Cartesian coordinate system. So we know how to plot a point, we know how to plot an equation. So we're really just continuing with that sort of idea. We want to talk about, first, what is a function as opposed to a relation between two variables. So everything we've been talking about so far, when we looked at something like this, this is a relation between x and y, right? This x variable and y variable are related somehow, right? There's some relationship between the two, and if we wanted to graph this equation like we said in chapter 1.1, we would solve this equation for y and say y is negative 2x plus 7, and then we would set up our little table like we did in chapter 1 and choose values of x and get values of y and then plot those points on the graph, right? If we let x equals 0, we get y equals 7. If we let x equals 1, we get y equals 5. We see that this is a straight line because x and y are both raised to an exponent of 1. So really all we need is 2 points. We'll just use 3 just to be safe. That gives us 2, 3. And then we would graph this on our Cartesian coordinate system. 0, 7, 1, 5, and 2, 3. Draw a line through those points. 1, 2, 3, 1, 5, 0, 7. And we graphed the equation of the line. That's what we did in chapter 1. So now, in addition to this, we want to define what a function is. So whenever we're given an equation like this with x and y, we want to determine whether it's a function or not. So a function, the definition of a function is, we're going to call what we've been calling the y, the output, right? We said this is the x variable, the independent variable, and we call this the dependent variable. When we see this term f with an x in parentheses, we call that f of x. We say f of x because we're basically saying given an x of 2, f of x, once we put that number into the equation, we get an output of 3. So these are equivalent variables, I guess we can call them. F of x is the same as y, right? So f of x, the definition of a function is that each x value can have at most one y value associated with it. Right? There are 3 different ways you're going to be asked this question. 3 different ways. So let's go over the 3 different ways. Okay, so sometimes you'll be given a relation between x and y with just a set of ordered pairs. Let's say I have the ordered pair 1, 2, the ordered pair 2, 1, the ordered pair 3, 4, the ordered pair 1, 4, and 5, 2. Okay, now these are just points, right? So this is a relation. Anything we look at that involves x's and y's is a relation. The question we want to determine is it also a function? It's always going to be a relation if it's x and y. We want to determine if it fits this description. So when we look at this is x's and y's, right? First number is the x coordinate, second number is the y coordinate. So for an input of x equals 1, we have an output of 2. But over here we also have an input of 1 with a different output of 4. So that doesn't fit this description, right? That x value of 1 can have at most 1, y can have none, right? I mean, 7 here doesn't have any output. That's okay. But it can have at most 1. whereas the input of 1 here has 2 outputs. So this is not a function, right, because of this. Not a function because 1 has more than 1 output. Right, so that's kind of the easiest form of this question when you actually are given the points. And all you got to do is look at them and determine if any of them have more than 1 output. Now if we were to graph that, and again remember those are just points, we're not connecting those points, those are just individual points. So if we graph that, let's go 1, 2, 3, 4, 5, 6, 7. Not got any negatives over there, right? Okay. So 1, 2 is on that graph, 2, 1 is on that graph, 3, 4, 1, 2, 3, 4, 1, 4, and 5, 2, 2, 3, 4, 5, 1, 2. All right, so it's just those points. Now another way to determine whether a relation is also a function. Again, remember, they're all relations. We're trying to determine if they're also functions. So the vertical line test says, if I can take any relation, okay, so this is a relation, I graphed it. If I can draw a straight vertical line perpendicular to the x-axis, okay, so any line like this, perpendicular to the x-axis. If any vertical line perpendicular to the x-axis goes through more than 1 point, which it does here, and it's not a function. I mean, all these different ways of determining are really the same way. It's just different ways of looking at it, right? Here we're just looking at the number 1, which has 2 outputs, so we know it's not a function. If we were just given the graph, we could see that a vertical line goes through 2 points, which again disqualifies it as a function, right? So the vertical line test is just this. You draw a vertical line anywhere along the x-axis. If it goes through more than 1 point of a graph, then it's not a function. So examples like a circle. We have a circle, that's not a function, right? Because it doesn't pass the vertical line test. It goes through more than 1 point, so this is not a function. It's still a relation, but it's not a function, okay? Vertical line test. What we've talked about so far, parabolas. Parabola, that's fine, right? There's nowhere I can draw a vertical line that's going to cross through that more than once. So yes, this is a function. Okay, so this is, I think, the easiest method, right? You're given the picture. All you got to do is look at vertical lines along the x-axis and see if it crosses more than once. Again, realize it's the same idea as what we just looked at over here. It's just a different way of looking at it. So that's the second way. So the first way, you're given a set of points. Again, you're not connecting these points. These are just individual points. But still, it doesn't pass the vertical line test because it goes through more than once. So again, this is not a function. Does not pass the vertical line test. We say it passes the vertical line test in this case. Pass the vertical line test, it is a function. Does not pass is not a function. Does not pass, not a function. All right, and then the third way is if you're given the equation. So we've looked at the vertical line test, we've looked at given a set of points, and now we want to see the third case. Let's look at something like this. Okay, I guess I'll just make one. All right, so what you're going to do here, again, remember the definition. It all comes back to this definition. And this is the key. Every method really is just looking at this definition in a different way. So if we don't have the picture, and we don't have the points, all the points, because it would be impossible to come up with every point on this function to check. The first case, we're going to solve this for y. Right? So we get negative 2x plus 7. So really, your clue here, again, looking at this definition, each x value, so you're going to ask yourself, if I put one x value in, is there any possible way that I'm going to get more than one y? every individual x value here is going to give you a different y. And the way, you don't, if you say, well, how do I know that? The way you know that is looking at the exponent on the y. If you look at the exponent on the y, in this case it's a 1. If the exponent on the y is odd, then it's going to be a function. But if the exponent on the y is even, then it's not going to be a function. Okay, so this one is a function. Yes, a function. Each individual input gives you at most one output. The definition. But now, if we look at something like this, if I just put a square on that y, then I solve for y. Now when I take the square root, remember I'm going to get 2 solutions. Each x I put in here, I'm going to get plus this value and negative this value for y. Therefore, it does not pass the test for functions. Exponent was 2, right? So even exponent, this is not a function. Okay, so that's the third one. So 3 ways to determine whether a relation, again, everything we look at is a relation. We want to determine whether it's a function or not. 3 different ways, given a set of points. Just inspect the points to see if it fits the definition. Given the graph of a function, the easiest way, vertical line test. Given the equation of a function, really all you got to do is look at the exponent on the y value. If it's odd, it is a function. If it's even, it's not a function. Okay? That is relations and functions. So we also want to evaluate functions. We want to, once we determine that something is a function, we want to be able to put x's into the function and come up with the outputs or the y value. So again, when we say a function, we read this as f of x equals y. It's the same thing, right? The output of a function. This is the input, the x. And this is the output, the y's. The inputs are called, all the possible inputs are called the domain of the function. All possible inputs. And the range is all the possible outputs. Okay, so given a function, we want to take any input and be able to put it in and get an output. And then we also probably want to graph it, look at it, inspect it. That's really what we do in these classes. So let's say, and sometimes I'll just put the y, sometimes I'll just put the f of x. Here I'll put both just to signify that they're the same thing. And let's say we have something like this. So this is a, first of all, you want to say, is this a function? Well, I already named it a function, so we know it is, but if you weren't given this and you were asked if it's a function, y is raised to an odd exponent, so immediately you know, yes, it is a function. Okay, so if we want to evaluate this function, evaluate f of x for, let's say, x equals 0. If x equals 0, what we're saying is if we put 0 into the function, right, f of 0, this is read as f of 0, we're putting 0 in for x. So we get 2 times 0 squared minus 7, or we get negative 7. Right? That's evaluating a function. This tells us that the point 0, negative 7 is on the graph of the function. Okay? And then we can put any other value we want in. Let's say x equals negative 1. So we want negative 1 to be the input. So we put that negative 1 everywhere we see an x. 2 times x squared minus 7. So negative 1 squared is 1. 2 times 1 is 2. 2 minus 7 is negative 5. That tells us the point negative 1, negative 5 is on the graph. All right, so if you're asked to graph a function or evaluate a function, This is what you're doing. You're putting in x values into the function, calculating the result, getting an output, which gives you the points on the graph, right? And you can draw as many points as you like until you start to see the shape. As soon as you see this one, hopefully you recognize that this is going to be a quadratic because the highest exponent is 2, so it's going to have that parabolic shape. Another thing I think I might have failed to mention about quadratics is the number in front of the x squared is going to tell you whether it opens upward or downward.